Hi there, Year 6. I hope you're doing well. Welcome to the maths lesson for today. Remember to pause at the right moments so that you can answer the questions, so that you can have a think about it. In terms of where do you write, you've got two exercise books at home, an English and a maths one. So all your maths can go in the maths book, just as if we were in class. And I really look forward to seeing those in a few weeks' time. Let me show you my screen and we can get going. So there we go, boys and girls. That's the learning objective for today's lesson, square and cube numbers. So if you can make a note of that, put the date on which you're doing the lesson and underline. Okay, let's get ready for the review section. Now here are 4 questions. Have a pause, have a think before we reveal the answers. Remember that prime numbers only have 2 factors. So 2 times 2 times 2, or 2 cubed. 9 times 9. So we were talking recently as a class, and Poppy, you'll remember 9 times 9 is 81. That's the squared number. And then we have another cubed number, 5 times 5 times 5. Hope you got on well. If you made any errors, if we have any questions, remember contact us through Dojo. So either myself or Mrs. Robinson, we're very keen to help and support you. So we're going to go through the lesson together. I'm going to say a few key points as we go through. When I'm not speaking, you'll be watching the animation. You have the control over when you pause, if you need to rewind, so you can go at your own speed. Which of these numbers are square numbers? How can you prove it? Have a think. Now I think I'm just going to draw your attention to this particular model, because the fact it creates a square is a really important point. For me, this is almost where the name comes from. So if you were to have a look at this, which I guess you would call an array, we've got 4 here and 4 here. So we've really got a multiplication array. And because there's 4 and 4 and 4 and 4, we know that when each of the 4 sides are of equal length, we have a square. I think it's a really powerful way of representing certainly very small squared numbers, and then it helps you imagine and have a picture in your mind to help you with other maybe bigger numbers. So is that a square, I wonder? No. So in this case, whilst each of these lengths are 3, we don't have a complete square because there is nothing there. So, square numbers in summary. The result of a number multiplied by itself. So one number multiplied by itself. Have a look at the squared numbers all the way up to 12 times 12. Make sure you know those. It's a really great way of also practicing the times tables. It has to be a whole number. I remember us having a discussion around that. I think Harry was questioning whether there were numbers that were decimals that could be squared numbers. So we're saying they have to be a whole number. And it has to be a complete square. So not just the perimeter of the square, but the internal part of the square as well. So there's the mathematical representations of 2 squared. We have the 2, and then when we were talking recently about the indices. So if that was in a calculation, of course, and you were thinking about the order of the operation, this would be right at the top alongside the bracketed ones. So 2 squared is the way that we can say that, and 2 times 2. So just to say that sometimes people might say this is 2 to the power of 2. So cube numbers. The result of a number multiplied by itself and then multiplied by itself again. So let's have a look. We've got 2 cubed, 2 to the power of 3. 2 cubed. 2 times 2 times 2. Commutative, so it doesn't matter which way round it goes. Of course, Tom will check if I am saying that right. He knows that that's one of the harder words to say. Commutative, I think, is actually a better way. Maybe Tom, give me some feedback. So it's interesting here that the representations are 3-dimensional. So we have, instead of a square this time, which is a 2-dimensional shape, when we build up the cubes, we have a 3-dimensional shape with the X, Y, and the Z axes. How many cubes do you need to build a 4 by 4 by 4 cube? Have a think, pause, show your workings out and your reasoning. How did you do? I would say not necessarily easy to draw that. So what you would do is you do the 4 times 4 times 4, work it out, and then you can say how many cubes you have. Of course, don't let me put you off drawing it if someone wants to have a go. So it's checkpoint time. This is going to allow you to decide where you're going to take your learning next. You'll notice that after the checkpoint, the advice is to do all of the questions. However, as in class, I'm very happy for you to leave out some of the very early ones if you think those are particularly straightforward for you. But with all of the questions, please do show your workings out, do show your reasoning, and please do remember to present your work in a legible way. So true or false, some numbers are both square and cube numbers. So you want to pause here, have a think about it, check out your reasoning, come up with any examples to prove or disprove it. So it's true. And for example, 64 is both a square and a cube number. So have a go at the questions. Good luck. Think hard. Go back to the slides if you need to refresh your memory. And I'll be a little bit quiet for a few moments, and you'll pause, and I'll see you with the answers shortly. So I hope you found that okay. It's always good to have a little bit of a struggle. So if some of them were a little bit harder and got you thinking, you know, that really shows your learning. I recently was thinking that if you can't explain something well enough for somebody else to understand it, then perhaps you don't know it well enough. So you could try that out. Find somebody that you can explain squared and cubed numbers to. Okay. Before we finish today, some additional practice for you. So have a read. So at this point we have a visual representation, then a formal written method. Remember how to do that. The key point, I think, with the formal written method is remembering the place value. Maybe some of you would like to challenge yourself by making an estimate. Have a think about this. What if Dexter was working out 17 squared and Annie was working out 17 cubed? So with the subtraction here, remembering the exchanging. Even though a lot of you are, of course, expert subtractors, occasionally we end up with 9 subtract 3. How else could we represent that? Pictorial method. Moving into a more classical formal method, again remembering your place value, perhaps estimating, so that should you make a calculation error, it will stand out to you. You'll know that it's evidently wrong, and you can go back and you can check. So stop and have a think. What's the same and what's different? Wonder how many different things you can come up with. How many examples of similarities? How many examples of differences? So when Mo adds two numbers, he gets a prime number, and when he multiplies them together, he gets a square number. Excellent. I'm just going to bring it back to full screen. Well done today. I'm really looking forward to hearing how you got on with squared and cubed numbers. If there are any misunderstandings, if there's something you would like clarification on, do get in contact via Dojo. Do find other ways to explore numbers. Enjoy the rest of your learning today, and take care.